Thank you for staying with the course to this last of the lessons. We've followed Einstein across many different fields. We followed his interests in the fundamental aspects of physics, space, time, simultaneity, the nature of matter, the nature of light, the nature of gravity, the structure of the universe as a whole. We've looked at his relationship to technology. We've looked at his relationship to politics, to art. We've looked at the way that Einstein's work has shaped poetry and painting and architecture. We've looked at the way that Einstein was taken up by philosophers in support and in opposition to Einstein's views. Einstein's conception of physics shaped a century. In fact, you could think of the 20th century as a century of Einsteins. Einstein, of course, was the person who pushed forward Ludwig Boltzmann's idea of the granular nature of matter, of real molecules and real atoms that constituted gases and liquids and solids. It was Einstein who took the statistics of these tiny fragments of matter and made them into a systematic, applicable domain that could predict things that thermodynamics was incapable of predicting, that could actually show the tiny motion of a suspended colloidal particle in a liquid, something that thermodynamics was completely unable to do. So he was able not only to show, as Boltzmann had, that the statistical mechanics could capture talk about temperature and thermodynamics in general, but also do things that went beyond that, that gave a real structure, a reality to atoms and molecules, to their sizes and to their qualities. But Einstein was also the scientist of continuity, the person who criticized ideas of space and time and took Minkowski's idea of space-time and made it into an enormously productive fabric of reality that governed not only general relativity but introduced cosmology to a new form of scientific structure that made cosmology, in a sense, the discipline that it is today, the discipline that makes experimental or observational cosmology a possibility. Einstein was interested in causality, in realism, in completeness. He wanted to see the connections of things in the world, and he believed that ultimately our picture of reality could give us a glimpse, a map of reality full stop. He wanted our representation of reality to map like hand in glove onto the world. He hoped for a kind of unification of all the different kinds of physics and the relationship of the sciences. He hoped that that universalism would extend also to politics, where he detested the divisive politics that led to militarism, nationalism, and war. He wanted a religion that went beyond the doctrinal separations that made sectarian struggles and led to the genocidal policies of World War II. He wanted a religion that was somehow deeper than that connected the different kinds of religion together into a principle of a graspable order in the world, something that, as he put it, scientists really had to believe in order to devote themselves, to devote their whole lives to trying to uncover an order. He was somebody who fell into the nuclear world in a certain way, whose work became important for those who uncovered the splitting of the atom and built it into an atomic bomb. He played a role in alerting American authorities, especially President Roosevelt, to the possibilities of nuclear weapons. And he devoted much of his later life to trying to avoid the catastrophe that might follow were nuclear weapons used in a determined way in the fight among nations. But Einstein's engagement with technologies, with real objects, began very early. He was always interested in devices. The compass, the magnetic compass, is one of the first memories that he has that led him to thinking about what science was and what it was that objects used to connect themselves to other objects. He was interested in the patent office and all that he saw in front of him, all this parade of world-transforming technologies. His fundamental contributions leading up to the great number of papers in 1905, in a sense, were each connected to real-world difficulties the real-world difficulties of technologies like the dispersion of smoke, the sign and symbol of 19th century industrial progress. And Einstein used his understanding of the motion of these smoke-like colloidal particles as the starting point for his inquiry into what became ultimately his explanation of Brownian motion. Generators. All around him, Einstein could see the burgeoning electrical industry, these huge new electrical generators that were lighting up cities across every continent in the world. He used that problem of generators and this question of how magnets and coils moved and produced electrical current to motivate the starting problem that becomes his special theory of relativity. And the lamp itself was what physicists then and now call a black body. The filament, as it was heated by the passage of electrical currents, glowed. What was the frequency of that glowing? How would it look across the different frequencies depending on the temperature of that wire? And it was those sorts of questions about filament-like objects that drove the studies of black body radiation and led Planck to his first preliminary notions of the quantum absorption and emission of energy, but then led Einstein much further in introducing the quantum of light itself. Technology, the theories that Einstein came up with about physics, his hopes for the metaphysical structure of the world, for a complete representation of an outside order, all of these formed Einstein's conception of a physics in tension between metaphysics and machines.